Okay, problem number 2786. Visit array positions to maximize score. You are given a zero index integer array nums and a positive integer x. You are initially at position 0 in the array, and you can visit other positions according to the following rules. If you are currently in position I, then you can move to any position j such that I is smaller than j. Okay, so you can move like previously. For each position I that you visit, you get a score of nums I. And if you move from a position I to a position j, and the parties of nums I and nums j differ, then you lose a score of x. Return the maximum total score you can get. Note that initially you have nums at 0 points. Okay, so I think we can play with the examples a bit. So let's have 2, 3, 6, 1, 9, 2, and okay. So first class. Oh, okay, it's positive integer array. Can we have negatives in it? No, it's only have positive integers, and it is larger than 0. Okay, and there are at least 2 numbers in the array. Then how come we don't we can move all through the, you can visit other positions according to, if you are currently in position I, then you can move to any position j. So forth. But can we move if 0, 2, Oh, j should be larger than I. If you can move to any position j, and so when you move, if the value is different, then you lose a score of x. Okay, and this x is equal to 5. So yeah, so you will start it at 2. You can have a score. This you get 2, and then you will get I can move to 3 then, but I will have to minus 5 because this differs. So minus 5. And it's 0. And I can move to, I can move to any 2, 6, 9, and 2, 6, 9, 2, 619 minus 5. Why only minus 1? You move from a position I to a position J and the parties of nums I and nums J differs, then you lose a score of X. Yeah, okay, sorry. From 2 moving to, it is moving to 6. But why 2 to 6 doesn't, like, there is, okay, the parties means, the same parties means it is odd number or even number. So yeah, like it don't want us to change a lot of numbers. If we change, then we will lose score for X. So we'll start at 2, then we move to 6, then we will not. The parties doesn't change, and yeah, like when you should change, like when you change the parties, get the maximum parties, get the maximum points in the parties in your party, yeah, and then change to another one. So if like 6, and then if you want, because we want to get the 9, so we move to 1, and this makes us lose points 5, and yeah, we will get 9, and the total will be 13 points. Okay, so I'll say, okay, so I think we have to know like which parties are we like the previous scores have, like, yeah. So okay, so for each value, for each element in nums, we will get our points, yeah, and I'm thinking, okay, if we are at this if we are at this element, like we can choose, we will be coming from, like if we don't get to this step, then it will be since there are 2 parties, I think I will have like okay, if to maximize the score, so if I am at 2, the end of the array, it like we can have select ourselves or don't select, and if we select, then there will be finding the parties of ourselves or same as ourselves, or find the other parties, like change to another party, but lose some points, like lose the X points, and see these three options: no select, or changing parties, or stay with the same party, which gets the maximum score. Okay, so that it will be if nums I I will say at I position, you come from you will be coming from find if you are standing at the I position, there are three options. One is do nothing, don't do nothing, don't move to I, or move to I, and so that means previously had which means the score will be or move to I. At I position, if you are standing at here, if you are standing at that's at 2, the last element of array, we can choose not to move here, so we will stay the same, and the other options will be move to I, and so if do nothing, the score will be the same as previous. The same as the previous ones. Or we can move to I, and the score will be if if I is I will be previous score plus num I, and but if parties differ, then minus X. Okay, so I think I will do, it has and the previous score will be calculated as the same thing, so it is repeating the problem, so it can be done by dynamic programming. And I will first use a recursion solution to solve the problem. And for recursion, I will have DFS, depth first search, to implement. And I will define DFS as I and P. P stands for the party, and so party will be, I'll say 0 and 1 as 0 will stands for even number, and 1 will be stands for odd number. So P, the definition of DFS IP will be the maximum score from nums 0 to nums I, where where the current where we expect to I'll say where the current party is P. P will be 0 or 1, and okay. So for this, DFS I will be maximum DFS I minus 1. If we stay the same, do nothing. And if we choose to move to I, and it says it wants to find 0 party. So okay, this will be 0, and this will be 0 plus nums I, or DFS I minus 1. If we change a party, then it will be nums I minus 4. The X. I am thinking maybe like if nums I like if we want to form this, like if we want to find if we currently is in the 0 party, then if nums I is an odd number, then we will be if we choose this option, if we choose to move to nums I, then if it is an odd number, the before is 0, then we will we should add the lost. So I will write it like this. But if it is not, it will be 0. Is it like this? yeah, this means that if we count do nothing, if we count from okay, so for so if we are now if we are now finding odd numbers, then if we are now looking for odd numbers, then if do nothing, it will be odd number in the previous, it should be previous, coming from previous odd number scores. It can be coming from it can be coming from an even number, then if nums I is an odd number, then it should be added a last. Or if it is an even number, then if this is so because we come from if we're now looking for an odd number and we come from 0, like we come from an even number, then then we should add a loss no matter which. Okay, it's a bit complicated. Okay, so like if we can look at 9. So the current number is 9, and if we come from an odd number, like the previous thing is odd, then like DFS I minus 1, then this would be, then we don't need to do anything if nums I is but if nums I is an even number, then it should be added. But I don't think like this has to do anything with I don't know how to define this P. Since this P seems to relate to the current nums I, or we can maybe okay, if I think I will first remove the P since it is like interrupting everything. So I will have DFSI, and yeah, it will be the maximum score from nums I, 0 to nums I. And okay, it will be, so DFSI will be the maximum score. Like if we don't select the current thing, it will be the score of the previous one. And or there's another option that is we select this, but oh, I still need to know, like, yes, because I need to know the previous, like the last, like the previous score. I don't know if I can use if just, I'm not sure if if I minus 1 means selecting nums I minus 1. If yes, then I can compare the party of both and check if it is the same or not. Okay, so I am thinking like we cannot use like DFS I minus 1 here will be 2, but it does not include, and this is not a good if we if we do it like a sub-array thing, like we count on every score ending that ends at nums I think it's not feasible. Okay, for every element it can select or don't select, since it is a subsequence. I think I'm in the right direction, but just like the state here is a bit complicated that I can't, I'm not really clear. Like, this has no problem, just for the one we don't select. We will do the nums later on. So we can first remove okay, so that's defined, like the current party is 0. So to make now, but if the current value is not even number, then this will not be correct. Okay, so let's say if nouns I if nouns I is an even number and there's another option that DFS we can come from an odd party. So if this, then we will have to minus x. And this is the condition that if nouns I is an even number. And if it is an odd number, then we will have kind of like this. This will be, we can come from an even number array, and this will be odd. But there will be another situation that is if nouns I is an odd number, and what will we do to make this? I think this will not, this or maybe we can stay with this two condition and let's start, since it is a time time complexity will be O n, since parties will be only two. Okay, so let's start with n equals nouns length, and we'll have the function dfs I and p, and we will do the boundaries later. And the other will be if nouns I is an even number, then we will return DFS. We'll return this stuff. And it comes from even number, comes from odd number, and if we don't stack, then okay. Else, it will return. I'm not sure if I don't I ignore the p. Does that? And for the answer, it will return DFS n minus 1 with I think the party of the first first element and the boundaries will be if if I is smaller, if I equals 0, return I. I don't know if we start like from 0, it will be better. Not sure, let's try. Okay. Maybe we can start with 0 and okay, I want to check the solution. Oh, it should. Oh. Okay, so it is like, kind of at the right direction, but okay, it says if norms I is, I think, we will start from 0, it will be easier. So for I, like, if we started from the first value, then it will be, it will be I, maximum score from I to n minus 1. And for I, 0, so if if current like this question, like this array, if the first value is it is an even number, so if it's an even number, then it's the solution set, we will definitely have to choose. We will start from looking at 3. Okay, we will start from okay, so if 3, it is an odd number, so this one, and we will definitely have to choose 3 as it is a positive integer, so it will be that the maximum sum to be larger. And okay, so we will remove those that thing, so it will only be like if it is so it can be coming from so when now it is 3, it is an odd number, and so I'll say when started at 0, this 2, it is an even number, and the next question will be finding the maximum score from nums I plus 1 to n minus 1. So finding the next problem, if we find so there's no there's no option for don't select, since this array all contains positive integers. It is most profitable, I'll say profitable, to select the number if it has if there is no loss. So we will delete this option, and if then since since 2 is an even number, if we want to find an even so for the next problem, if we want to find an even number, then we can just edit the current value, but if we want to change to an odd number, then we should add the loss. Okay. But we can also don't select if like if nums I is we can check if nums I is an odd number like 3, then for the next problem, it will be for the next maximum score from I plus 1 to n minus 1, it will be the next value plus the current value. And if it comes from if the next problem is to find an even number, then we should add the loss value so that we can change. But for I'll say if okay, so if okay, so if I0 is 2, means the 2, then when we consider 3, like choose or not to choose, if 3 is an odd number, so we can, but 2 is not an odd number, so so if it differs, then we have another option that is don't choose, like, so we will have DFS I plus 1 with 0. Since we would continue the previous party, and for this it will be DFS I 1 and with DFS I plus 1. So this will be if it's an odd number or if this is an even number. Okay, so to write this, then we'll start from 0. Okay, I think we can start it from, let's start from 0. And if I is, let's do the boundaries later. Then if nums I is an even number, then let's have this can I do if nums I is an even number and if p equals 0, else ignore, like don't select. Then if nums I is an odd number, then if p is odd, else don't select. And the boundaries will be if this should be plus. I did not. as well. Oh, it should be ignored. Plus one of yes, correct. Then we will start from 0. For boundaries, if I is let's see if yeah, we don't want I plus 1 to be out of bond. Zero. So yeah, like the first element will be nouns 0 and it will be 2. Not sure if this starts with neg. No. So for yeah, I will start it by 0, and yeah, then so we can add the first number, then yeah, so when it is larger than n, so it will be n minus 1. If it is at the end of the array, we should return let's say, I think 0. Yeah, since it is sum. Okay.